All right. What did you guys want to talk about here? Okay. You just want to do one as an example? So here's the idea, and I'll do more work than really maybe we need to so you can kind of understand what the idea here is. So I'm going to start with these three zeros that were given. And I'm going to start by rewriting these so that they're equations that are equal to 0. So just like I'll add 5 to both sides, and then subtract 3 from both sides, and then subtract 4 from both sides. Okay with that? And now I'm going to multiply these three equations together. So when I do that, I'm going to multiply the left-hand sides together. And then I'm going to multiply the right-hand sides together, but 0 times 0 times 0 is just 0 still. Okay with that? So let's look at what I did here. I took these three solutions and I converted them into three equations that have that particular solution, right? And then I multiplied those three equations together to get one equation that will have those three solutions to it. Does everybody kind of see that?
Yeah.
We're not quite done yet. I need to worry about the leading coefficient.
Yeah.
So all I'm going to do is write that there. In the case of, for this problem, since the leading coefficient is 1, it doesn't really need to do anything. The last piece that I have to worry about, though, is we wanted our answer in standard form. So that just means that I'm going to multiply this all out now. Okay? So if I FOILed out x plus 3 times x minus, or x plus 5 times x minus 3, I get that. I just did that in my head. If you have to FOIL it out the long way, that's fine too. I just did it quickly in my head. And then I'm going to FOIL these two out. So I'm going to do x squared times x squared times negative 4, 2x times x, 2x times negative 4, negative 15 times x, and negative 15 times negative 4. So my final answer then is x cubed minus 2x squared minus 23x plus 60. Everybody okay there?
If your AN is greater than 1, please multiply that before you FOIL everything.
You could do it in any order. Whether you want to do that first or last or somewhere in the middle, it doesn't really matter when you do it. Okay. So let's do 10 then. Let's start 10 though, just with this step, because we don't really need to probably write out the stuff before then, right? You guys, now that we understand how I'm getting to that step, we probably don't need to write out anything before that step. So what am I going to write here for 10? What's my first factor? So what am I going to write? Not 2, not negative 2. X plus 2. Thank you. Okay. And then what? Okay. When it says double, what does that mean? Just means we're going to do it twice. Yep. what that means, it's a double root. Remember when we did some of these solving problems, we get the same answer more than once? That's what it's saying there. Okay, and then there's one more thing we need to do before we start multiplying this out. We need that coefficient of 2. Everybody okay there? Okay. So I'll leave that for you guys to FOIL. Sound good? Okay. Take a minute, try to do that. See if you can see what you get. I'll write the answer up here in a couple of seconds. So the answer, when you FOIL that out, should have been 2x cubed plus 8x squared plus 10x plus 4. So what do you guys think? No big deal on these then?
On the last one, it says triple. So does that mean there's 3 more than 3?
Correct.
So that you FOIL all those together.
Yep. Yep. So you guys want like another day to kind of finish this part up and we can talk about the rest of this tomorrow or whatever? Sound good to you guys? Okay. So we'll do that. And then we're going to finish up chapter 13 today. So tomorrow we'll take any last questions we might have, and I'll get you guys your review, and then I don't think we meet again this week, right? Maybe Thursday. I don't want to test on that weird half day though. So we'll probably test the first class day next week. I'll get it on the calendar. I'll probably just start a little bit of something on Thursday then and just not do, won't go very far, but we'll get something started that day. Okay? Okay. So in section 3.4, or 13.4, excuse me, we're going to talk about complex zeros and the fundamental theorem of algebra. When we say the word complex here, what are we talking about in regard to complex zeros? We've used this term before in mathematics. So what we're referring to is a complex number, something in the form a plus bi. If you remember back to your algebra course from last year, we would have spoken quite a bit about these complex numbers. Okay. So the first thing we're going to do is give a statement for the fundamental theorem of algebra. I'm just going to abbreviate that as FTA because there's a whole lot of letters I just don't want to write again. And what this says is that a polynomial of degree n will have exactly n complex zeros So remember that the complex numbers include the real numbers and the imaginary numbers. And when we count those solutions, we're also counting repeated solutions. So even though say I was supposed to get 5 solutions and I got 1 and -1, if 1 was used, if I got that solution twice and -1, I got that solution 3 times, that still counts as 5 solutions. Okay, so we're definitely still counting those repeats. Okay, so let's look at this example. Here we're going to be asked to write the polynomial in standard form and then to identify where it crosses the x-axis. So the first thing that I would want to do is I would want to multiply the pieces together that have the imaginary parts in them. So the first part of this multiplication to get it into standard form that I would want to do would be this part. Everybody's okay there? So when I FOIL this out, I get x squared plus ix minus ix minus I squared times x plus 5. When we combine like terms inside that set of parentheses, what do you notice happens? I have a plus ix and a minus ix, so those are going to cancel out. And then I have an I squared. Do you guys remember what I squared equals? So remember the complex number, or the imaginary number I was equal to the square root of -1. So what is I squared going to be then? -1. So I'm going to replace my I squared with a -1 there. So that first set of parentheses then just becomes x squared minus a negative, so plus 1. And then I just have this guy to FOIL. So there's my standard form polynomial. And then where is this going to cross the x-axis? Remember, I can find the places where the polynomial crosses the x-axis by setting each of the factors equal to 0. But I is an imaginary number, so is that going to represent a place on the x-axis? No. So those ones don't count. Only x plus 5 is going to represent a place on the x-axis. Where on the x-axis is x plus 5 going to correspond to? What? Not 5, because remember we're setting these equal to 0. -5. Yes. Another important theorem is called the complex conjugates theorem. So what the complex conjugates theorem says is that for a polynomial with integer coefficients, if a plus bi is a 0, then a minus bi must also be a 0. When we have two things that are the same, except for the sign in between them, we usually call those conjugates. It's like they make up the two parts for a difference of two squares. Okay. So let's look at an example. Okay. So let's say we want to write the polynomial in standard form that has the lowest degree possible and the zeros 1, -3, and 1 plus I square root 2. So right away, I know that this list of zeros is incomplete. I'm missing a zero that needs to be there. And I know that because of the complex conjugates theorem. Because I have one complex zero, but I don't have its conjugate on the list. What other zero needs to also be on this list? One minus I square root 2. Is everybody okay with that idea?
Oh.
Because it's complex. Okay. So now I'm going to do just like we did on the worksheet. And I'm going to use these zeros to create a factored polynomial. So what factor does the zero of positive 1 give us? What zero am I, or what factor am I going to write from the zero of x equals 1? X minus 1. Okay. And then how about -3? It's plus 3. And then how about 1 plus I square root 2? So minus and then minus again, right? And then for this last zero, what am I going to write? Well, it's going to be -1, but then plus I square root 2. Because remember, it's like we're setting these equal to 0. So if I have this, I'd subtract the 1 over, and then I would add the I square root 2 over, right? So if you have to write it out to make sure you get all the signs right, do it. It's not a big deal. It just takes a second. If you don't need to, you don't have to. But if it helps you, at least till you kind of get the hang of it, you know, just do it. Okay. So let's FOIL some stuff out. So I'm going to FOIL these two together and then those two together. I always like to FOIL the complex conjugates together because the result that's going to happen is I'm going to get just integer coefficients afterwards, which is better than having all the i's rattling around in there. So first thing I'll do is I'll FOIL out x minus 1 times x plus 3. I just did that quickly in my head. Again, if you have to write that out and show the steps, do it. It's no big deal. It just takes a second. If you don't need to, you can skip it. As long as you can FOIL it, you can FOIL it. And now I'm going to FOIL these guys together. So x times x is x squared. Then x times -1 is -x. And then x times I square root 2 is I square root 2x. Okay? And I'm going to keep on doing that. So I get -x plus 1 and then minus I square root 2. God bless you. Then I get minus I square root 2x plus I square root 2. And then I get a minus I squared square root 2 squared. I'm sorry. The good news is it's about to get a lot better. Because look at what's going to happen when we combine our like terms there. I have a positive I square root 2x and a negative I square root 2x. So those are going to cancel. I have a negative I square root 2 and a positive I square root 2. So those are going to cancel. What was I squared equal to again? Negative 1. So I can replace that I squared with a negative 1. And what's the square root of 2 squared? It's just 2. So I can just replace that with a 2. Okay. So now when I combine my like terms in that second set of parentheses, I have an x squared. I have a negative x and another negative x, giving me negative 2x. I have a positive 1, and then minus negative 1 times 2. So that's plus 2, right? So that's going to give me positive 3. Everybody okay to there? And boy, that looks a heck of a lot better now, right? That's what should happen every time you multiply two of those complex conjugate parts together. You're going to get a polynomial with just integer coefficients. Won't be bad. Getting to that polynomial is kind of yucky, but the result will be something that's much more convenient to work with. And then we just now need to multiply these out. So if x to the fourth minus 2x cubed plus 3x squared plus 2x cubed minus 4x squared plus 6x minus 3x squared plus 6x minus 9. And when I combine these all together, I get minus 4x squared plus 12x minus 9. Okay. So if I want to find all the complex zeros for the polynomial x cubed plus 4x squared plus 9x plus 36, one way I could do this is I could try to use my synthetic division techniques on this. So I'll start by listing my possible rational zeros. How do I find those again? Well, that's what we're trying to do to find all the complex zeros. But I want to just start by looking at the list of things that I might want to do my synthetic division with. To get that, I'm going to be looking at the factors of the constant term divided by the factors of the leading coefficient. And since the leading coefficient is just 1, it doesn't really matter. I just need to look at the factors of 36, right? So what are the factors of 36? So 6 is one of them, positive and negative, 12 and 3, Okay, what else? 1 and 36. 13 does not work. 2 and 18. Still some more. 4 and 9. We already got 2. I think we have them all now. I appreciate it. Okay. Once I have my list, what do I like to do next? I want to look at the graph of the polynomial and figure out which one of these from my list looks like a good candidate to try synthetic division with. So let's fire up our old graphing calculator. What? Well, that's because you want to be able to graph it. Or that's the way to factor it. It's the only way that we have to factor it.
So why are we trying that?
Well, we can once we divide it down to something that's quadratic, but this is degree 3. Because those are going to give us the candidates to do the synthetic division with. Okay, so here's my graph. What am I looking for on the graph?
Where it crosses that.
Great, where it crosses the x-axis, which is one spot right here.
That's like negative.
That looks like -4. Try counting those tick marks again. I know it's far away and it's very small, but it's -4. Okay. So from the graph, I'm going to get -4 as my synthetic divider. How many zeros should I be seeing here? I should be seeing 3. I only saw 1 when I looked at it, though. What does that mean? Doesn't mean that it's wrong necessarily. So it means one of two things. It means either that solution is going to be used 3 times, or this has 2 imaginary solutions to it, in addition to the one that I can see. I don't know which one of those 2 situations it's going to be right away, but it's going to be one of those 2 situations. So let's start our synthetic division. So this tells me that my polynomial factors into what 2 polynomials? Because I got a remainder 0, I know I have what polynomial? X plus 4, right? Because I found x equals -4 is a 0. So I know that the polynomial x plus 4 is a factor, right? What other polynomial do I have left there also? Well, really just x squared plus 9. Remember, remainder, constant, x, and then x squared. Because the coefficient on x is 0, it just goes away, right? Everybody good with that? So now this is broken down into a linear factor and a quadratic factor, right? This is far enough factored down to where we can solve this the rest of the way. So to solve this, what I'll do is I'm just going to take each of these two factors and set them equal to 0 to solve. So this one I get -4, easy. We knew that was going to be a fact or a 0 anyways. How about x squared plus 9? How can I solve that? So it's not a difference of two squares because it's not a difference, it's a sum. David, you said...
Subtract 9 from either side.
Okay. When I do that, what do I have to be careful about remembering? So a couple of things. So when I square root both sides of an equation, what do I get when I do that? What do I have to remember to include? Plus or minus. Okay. When I square root a negative, what do I have to remember? There. When I'm square rooting a negative, what do I have to remember? It makes an I. And then what's the square root of just 9? 3. So there's my other two solutions. One for positive 3i and one for negative 3i, giving me two solutions there. When I count the -4, that's 3 solutions total, which is what I was expecting to see. Let's do one more, and then we'll be done. Sound good? Okay. Oh. How do we start one of these problems? Not -35 times 8. So we need the factors of 35. That's true. What are those? What else do we need the factors of? The leading coefficient. What are the factors of 8? Okay. And then we'll use these to make our list of possible rational zeros. So that's going to be the factors of 35 over 1. The factors of 35 over 2. The factors of 35 over 4. And then the factors of 35 over 8. Everybody's okay there. Okay. Next thing we do is we go graph the polynomial on our calculator and look at the picture. What we're looking for on the picture is we're looking for the x-intercepts, and we're looking for x-intercepts that also correspond to numbers on our list. We can only do our synthetic division with numbers that appear on our list. Numbers that don't appear on this list would be irrational solutions They'd be like things that involve square roots. And we're not going to be able to isolate those things with polynomial division. We'd have to find those factoring kind of by hand methods. So there's that. Let's hit graph. So I see two x-intercepts. I'm going to resize my window a little bit so it's going to be a little easier to see what's going on. So it looks like all the information that I'm interested happens between, say, -2 and +1 on the x-axis. You guys agree with that? So I'm just going to change this to -2 and +1 and take another look here. Okay. So what would you estimate this value at between 0 and 1? 1/2. Is that on our list? It does. Okay. Let's go back and look at the other one. So this is -1 and that's -2. What would you estimate this one at? -1 1/4 maybe? Because that's on our list, right? Right here. So we're not positive on either one of those because they're not crossing right at a tick mark, but they're the best we got. Everybody okay with that? All right. So let's just start with the 1/2 for the sake of this example. Doesn't matter which one you'd start with though. Is everybody good there? Here's the problem though. If I look at the polynomial that's left, what degree polynomial is this? So remember, remainder, constant, x squared. It's a cubic polynomial. Can I factor cubics by hand? No. So what does that tell me? No, we're just going to have to do another synthetic division. No solution. So I'll just do another synthetic division. Because when I do another one, what I'm going to get is something that is quadratic. Like so. Okay. So what are my factors now? So one factor comes from the 1/2. What factor does that give me? Did you say x minus 1/2? Another factor comes from the -1.25. Good. And then my last factor comes from this stuff, which is? Very good. Are we all okay there? So then I take each one of these factors and I set them equal to 0. And solve for 8x squared minus 32x plus 56. How are we going to solve that? So you say there's greatest common factor here that you want to deal with? Is that what you're saying? Okay. And you said the greatest common factor is? It's actually a little bit more. It's 8. So I can just divide both sides by 8. And that makes the numbers a little smaller, a little easier to deal with. Okay, that's fine. I would do that. Anytime I can make the numbers smaller, that usually makes our life a little bit easier, right? Now what? We're trying to solve x squared minus 4x plus 7 equal to 0. So Caitlin says one way we can solve a quadratic is by factoring. So we need numbers that multiply to give us positive 7 and add to give us negative 4. But we're drawing a blank as to 2 integers that'll do that. So if we can't solve this by factoring, what do we have to use? The quadratic formula. Okay. You cannot. You would have to do the quadratic formula here. It won't work. So 16 minus 28 is negative 12. And this can simplify a little bit. How can we simplify the square root of negative 12? So because it's a negative, we can do the I. Can we simplify the square root of 12 at all? Well, remember, 12 is the same as 4 times 3, right? So the square root of 12 can be the square root of 4 times the square root of 3. Do you notice anything there? What's the square root of 4? 2. So we can say that. And we can do a little bit better than this. Notice that if I write this as 2 separate fractions, I can reduce each of those 2 fractions. What do you guys think? So if you had like this step, probably not. But that is not an unreasonable expectation, is that you're able to like reduce fractions and stuff. So for tomorrow, you guys have a couple of problems on the back of the worksheet that you said you still need to finish up. And then I'd like you to try 44 through 53.